community. This platform aims to disseminate knowledge on diverse and emerging themes from cutting-edge technological advancements to sustainable and future-ready solutions, while enabling your young researchers across the globe to connect, exchange ideas, and collectively advance the field of transportation research. The series began with its inaugural session on 24th August 2023, concluded in an online mode, which witnessed the enthusiastic participation of more than 200 attendees from premier institutions and government departments. The inaugural address was delivered by Professor Dr. Tom B. Matthew, Chairman of the Research Council, NATPAC, and Professor at IIT Bombay, setting the tone for the session that followed. Since then, we have successfully organized 27 insightful sessions, each contributing significantly to the evolving discourse in the transportation engineering. Today, we are very pleased to host the 28th talk in this series. It is my privilege and honor to welcome our distinguished speaker, Dr. Anjali Balan, Assistant Professor, Department of Civil Engineering, National Institute of Technology, Calicut. We are grateful to Dr. Anjali for accepting our invitation and joining us to share her expertise on the intriguing and timely topic Bio-Bitumen from Algae, a sustainable alternative. Following the presentation, we will open the floor for question and answer session where you are encouraged to ask your questions and engage in a meaningful discussion with our speaker. Your active participation will undoubtedly enrich today's session. Thank you all once again for being here. Let us now extend our warmest welcome to Dr. Anjali Balan and look forward to an enlightening and thought-provoking presentation.
Thank you, sir, for the welcome. Now, I would like to invite Sri Tingu Casper de Silva to introduce the speaker to the audience.
Dr. Anjali Balan is an assistant professor in the Department of Civil Engineering at NIT Calicut from 2024. She holds a PhD in Transportation Engineering with a specialization in Pavement Engineering from IIT Delhi. She completed her MTech in Transportation Engineering from NIT Hamirpur and earned her BTech in Civil Engineering from Marine Engineering College, Trivandrum. Dr. Anjali has an active research profile with about 10 journal and conference publications, and she has participated in 7 international conferences. Her research interests span a wide engineering and sustainable materials, including pavement materials and evaluation, biobinders, rheological and chemical characterization of bituminous materials, and sustainability in transportation infrastructure.
Thank you, sir. Now I invite our distinguished speaker to deliver the talk. Over to you, ma'am.
Hello, everyone. Thank you for the warm welcome. So first of all, I would like to thank NATPAC for inviting me for this Transpedia Talk series. So I think we can start our session. I hope it is visible.
Yes, ma'am, it's visible. Okay, yeah, it's in full screen mode. Please go ahead.
Okay. So today our topic of our discussion, it is bio-bitumen from algae. That is an experimental investigation of the performance of bio-bitumen. So this is my presentation outline. So coming to the bitumen, so we know that what is a bitumen basically. So what is a bitumen? So bitumen, it is obtained from the crude oil by the fractional distillation process. So as we know that depending upon the difference in the crude oil source, the properties of the bitumen will vary. Its chemical fractions will vary, its properties will vary based upon the crude oil source. So bitumen, it is basically a hydrocarbon and it has a viscoelastic behavior. Since due to its viscoelastic behavior, it is an ideal material for the road pavements, and also it has a use for the waterproofing purpose also. And we all know that bitumen, it is a key component or a major constant of a asphalt mixture. So now we know that there has been an increase in the road construction in India, and India has the second largest road network in the world, right? So we know that the bitumen consumption, it has widely increased in India. So it is said that overall around 8.8 million metric tons has been reached. The bitumen consumption has reached around 8.8 million metric tons. And it is estimated that by 2024-25, it will reach around 10 million metric tons. So we know that there has been an increase in the bitumen consumption in India. So there is a huge demand for bitumen. So now we have to think about an alternative material which will replace the bitumen in a better way. Like it should be performing similar to that of bitumen, or it should be performing better than that of bitumen. So now we are in that process where we are in that thought process to identify a particular alternative material. So along with that, we know that there are certain challenges for the bitumen, right? So coming to the challenges of bitumen, we know that the bitumen it is not able to perform better under heavy conditions or heavy traffic conditions, and the bitumen it emits a high carbon dioxide, right? It because the greenhouse gas emissions it is higher in the case of bitumen, and we know that since there is an increase in the bitumen demand, uh, they are not able to find the good quality of bitumen, and also there is a source depletion and other environmental concerns related to this bitumen. So overall, there are certain challenges for using the bitumen, basically coming to the environmental concerns. So now we have to think about a sustainable alternative for this particular binder or the bitumen. So what comes as a sustainable alternative? There comes the bio-bitumen, which is a sustainable alternative for a bitumen, right? So what is a bio-bitumen now? So bio-bitumen, for the bio-bitumen, the raw material, it is a biomass itself. So what is a biomass? It is an organic material which can be obtained from a plant or animal matter. Okay. So bio-bitumen, it is obtained from the biomass. We cannot directly use the biomass in the bitumen. So it has to undergo certain process, and then we will be able to use that product in the bio-bitumen. So in the case of bio-bitumen, in the case of bio-bitumen, we will be replacing some amount of bitumen with the uh, this bio product or the bio-based material. Okay. So the basically used biomass sources are the rices, bamboo, wood chips, seaweeds, then the swine manure. All these are the commonly used biomass sources. So now basically this bio-bitumen, it can be produced in 3 different ways. So the first, it can be a bio-based material which is replaced, which directly replaces the petroleum asphalt. So in the case of a bio-based material, let it be a bio oil. So the researchers are now trying to identify a material that can completely replace a binder. Not they are partially replacing it, but we are thinking about a material which can completely replace a binder or a bitumen. And another is we are partially replacing the bitumen with the some amount of bio-based material where it can be less, where it is less than 10%. Then the another is it can be used as a diluent where replacement ratio or replacement rate is around 25 to 75%.
Dr. Anjali, right now
Uh,
the slides are not ready. Yeah.
Actually, there is an issue with the slides. Let me check this. I'm sorry for this delay. Okay.
Yeah, fine. That.
Okay. Is it
Yeah.
visible now?
Yeah. Please go ahead.
Okay. Okay. So we were discussing about the bio-bitumen now. So why we require a bio-bitumen now? So what are the properties of this bio-bitumen now? So coming to the properties of bio-bitumen. So if we are using any kind of bio-based material, it will be the properties of that particular bio-based material. It is similar to that of a petroleum asphalt or a conventional binder. Okay. And this kind of bio-based material, it primarily consists of the chemical fractions which is present in that of a conventional bitumen. So other than these properties, it is a very economical and environmental friendly material, and it is very relatively it is very cheap, and it can be a solution to this waste disposal problem, and we can reduce the emission of these greenhouse gases, and all these environmental concerns can be solved. And also it will be able to improve the pavement performance. That is a major highlight of the with the use of this bio-bitumen. So coming to the performance of bio-bitumen, there are various researches have been conducted in this bio-bitumen. So from those results, we came to understand that it is showing a better anti-aging property. So we know that aging is a major issue with the pavement. We have the short-term aging as well as the long-term aging. So with the use of this bio-bitumen, we are able to provide, or we are able to have an aging resistant material. And also it has improved the high and the low temperature performance, and it has improved or enhanced the fatigue resistance, and it could lower the high temperature stability. All these performance was enhanced with the help of the bio-bitumen. So for your reference, I would like to mention that the India has recently launched a bio-bitumen project for the Sustainable National Highway. So it was a NH 44 that was in Nagpur. So here they have used the bio-bitumen for the pavement construction. So what kind of bio-based material they have used? They have used a lignin, which is basically obtained from which is a waste product from the paper pulp industry. Okay, so they have used this lignin in the bitumen, and they have constructed a 1 kilometer road stretch with the bio-bitumen. So now we understood there is a bio-bitumen. So how this bio-bitumen can be obtained? So we have already discussed that the bio-bitumen, it is obtained from the raw material for the bio-bitumen. It is a biomass. So what is a biomass? Biomass, it is basically obtained from the plants, animals, and certain industrial waste. So we know that bio-waste, it is a major concern or the major environmental concern which we are facing now, right? So depending upon the type of the biomass, the properties of this bio-bitumen, it will be varying. And again, depending upon the type or the process through which we obtain the bio-based material, it will also differ the performance of that particular bio-based material. So we have discussed the commonly used biomass which have been used for the bio-bitumen. So these are the different biomass sources which have been used for the bio-bitumen. So now in this study, we have used the algae biomass. So why we have used the algae biomass? So it has a rapid growth. That is the one major reason. And another reason is that it has a high oil content, where this oil content will help the binder to soften it or to reduce the viscosity of the binder, and also it contains the proteins and the carbohydrates, and the other environmental reasons, like it is a biodegradable material, and it is a very environmental friendly material, and there is no other competition with other types of crops, and it will also help to reduce the carbon footprint. So these are the major reasons for selecting the algae biomass. So now coming to the production process, now we have chosen the algae biomass as a source or the raw material. Now we have to get the bio oil or biochar from it. So there are different types of production process for obtaining this bio-based material, that is a biochar as well as the bio oil. So depending upon the type of application and the source of the materials, the technology or the process will be different. So basically the biomass, it is subjected to a thermochemical conversion process where we use certain heat to transform this biomass into major products like the bio oil as well as the biochar. So this thermal conversion process, it includes a process like the combustion, gasification, and the pyrolysis. So here for the algae biomass, we have used the pyrolysis process. So basically if it is a dry biomass, we usually go for the pyrolysis process. If it is a wet biomass, we go for the hydrothermal liquefaction process. So in our study, we have used a pyrolysis process. So this is the overall production process where the thermochemical conversion process, it includes the gasification, pyrolysis, and the hydrothermal process. So within the pyrolysis, we will be getting the biochar as well as the bio oil, and within the hydrothermal, we will be able to get the bio oil. So this is the overall production process for the biomass. So now coming to the pyrolysis, as you all know, what is a pyrolysis? It will convert the biomass to bio-oil, biochar, and the non-condensable gases. So it is done under the absence of oxygen at a higher temperature, which is between 450 to 550 degrees Celsius. So using the pyrolysis process, we will be able to get the high bio-oil content. That is a major advantage with the pyrolysis. So again, the pyrolysis, it can be divided into the slow pyrolysis, fast pyrolysis, and the flash pyrolysis. So coming to the slow pyrolysis, here in the slow pyrolysis, we have a slow heating rate as well as a long residence time, where we will be subjecting this biomass for a certain period of time. So where in the slow pyrolysis, we have a long residence time, and the amount of product which we get from the slow pyrolysis, it will be less than the 50% of weight of the initial biomass. But in the case of fast pyrolysis, we will be having a high heating rate, and where it will be a short residence time. But the amount of product which we get from here, it will be higher when compared to the slow pyrolysis. Now coming to the flash pyrolysis, where the heating rate will be very high compared to that of the fast pyrolysis, and it will be having a very short residence time. And the bio product which we will be getting, it will be greater than 90% of the initial biomass. So coming to the pyrolysis process, how we have done the pyrolysis is, first we have the biomass, whatever is the biomass source. First we will dry it, which is to be less than 10% of the moisture, and we will be grinding it into smaller particle size. So once it is done, we will heat it between 450 to 550 degrees Celsius, and we will get the biochar from heat, and along with that, hot pyrolysis vapors will be formed here, and it will be condensed so that we will get the bio-oil from here. So from the fast pyrolysis or from the pyrolysis process, we get the bio-oil as well as the biochar. So at what conditions or what will be the amount of biochar we will be getting? So from the pyrolysis, we will be getting around 15 to 25% of the biochar, and from this we will be getting around 10 to 20% of biogas, and 50 to 75% of the bio-oil will be obtained using the pyrolysis process. So now coming to the biochar, which is a major product from the pyrolysis process. So biochar, it is a major product from the pyrolysis process. So it is a stable and a rich carbon material, and it basically consists of nitrogen, hydrogen, inorganic elements, and some traces of heavy metals will be present in that. And it is basically a porous material, and it has a large surface area. And these are the properties of the biochar, and it is said that it is highly resistant to the biological and the chemical deterioration. So the chemical composition of a biochar, it will depend on the process which we have adopted, and it will depend on the source of the biomass which we have taken and the method of analysis. So this I have taken from a research article where they have used a nutshell, and using the pyrolysis process, they have obtained the biochar. Is my slides visible now?
Yeah, it's visible. We can make it full
Actually, I'm
screen.
having some issue with the full screen. Once it is full screen, I'm not able to change the slides. So now coming to the bio-oil, which is a liquid substance which is obtained from the pyrolysis process. So again, it is a mixture with a high oxygen content, and some organic compounds are present in it. And it basically consists of the carbon, hydrogen, oxygen, nitrogen, and sulfur. So the major components, like if the bio-oil is derived from the different masses, it is found that it is almost the same. All the components are almost the same. There is not much difference between the components in the bio oil. That's what the research says. So basically, we go for the pyrolysis for the biomass from wood and the plant materials. If the biomass sources the wood and the plant materials, we will go for the pyrolysis. If it is with the biomass with a high moisture content, we will go for the hydrothermal liquefaction process. So now in the investigation which we have conducted, our objectives were to investigate or to evaluate the physical and the chemical properties of bio-bitumen, to evaluate the rheological properties, and to determine the partial stability of the bio-bituminous fixes. So the materials which we have used in our study was BG30 and then spirulina species algae. So in our study, I have already mentioned that we have used the algae biomass. So within the algae, there are different types of species which is available. So within the different species, we have selected the spirulina species algae. So why we have selected the spirulina algae species? So the major reason is the oil which is derived from the spirulina, it is rich in the fatty acids and as well as the phenolic compounds, and it is antioxidants. And the rheological properties of the spirulina algae oil, it was found to be similar to that of the bitumen. And another major reason is it is easily available within the Indian region. It is very renewable material as well as it is a cost efficient. And the performance of the spirulina, it was found to enhance the properties of the bitumen. So another major reason for the selection of the spirulina species is it has a lipid content around 35%. As the lipid content is more, it will be able to enhance the properties of the binder. So these are the experimental tests which we have conducted in our study. First, we have extracted the bio oil and biochar, and then we have done the EDX analysis, and then the conventional properties were done, and the FTR analysis were done, and aging was done. The frequency sweep test, MSCR test, and the Marshall stability was conducted. So this is the overall methodology of our study, like the initial materials which we have taken the BG30 and the spirulina algae species, the preparation of bio oil and biochar. From there, we will be modifying the bitumen using the bio oil and biochar. Then we have done the experimental investigation for the unaged as well as for the RTFO. For the unaged, we have done the EDX and FTAR, and for the conventional properties, again, the RTFO as well as for the unaged conditions, we have done the rheological testing as well as the FTAR analysis. So now coming to the extraction of bio oil and biochar, we have used the fast pyrolysis method. So in that around 90 grams of spirulina algae was taken and the temperature was around 500 to 550 degrees Celsius. And the time taken for the complete setup, it took around 30 minutes and around 1 hour was taken for the oil extraction. So the amount of bio oil which we have received is 27 gram, biochar 24, and biogas it was around 39 gram. So this was the overall process. We had the spirulina algae, and here it was a cylinder where we have filled with the algae, and this is the overall pyrolysis setup. And this is the pyrolysis unit which we have set around 510 degrees Celsius. So this is the final product or the bio-based material which we have obtained, which is a bio oil as well as a biochar. Bio oil which was in dark green in color. It was with thick viscous material, and the specific gravity was found around 0.95, and the boiling point was found around 180 degrees Celsius. So this was a biochar which we have obtained. It was in ash in color, and like pebble size, like sizes it was found. So now we have done the EDX analysis. So basically this EDX analysis, it is done to determine the elemental composition of a material. So now coming to the EDX analysis, we have the bitumen, we have bio oil as well as the biochar. So here we can see that the carbon component, the carbon in the bio oil, it was found to be higher than that of the biochar. Again, it was almost similar to that of a bitumen. And again, the nitrogen, it was also in the same range, and the oxygen was found to be higher in the biochar and less in the bio oil compared to that of the bitumen. So this is all about the EDX analysis. So now coming to the FTR analysis, where we will be able to identify the functional compounds which is present in the material. So we have done the FTR analysis for the BG30, that is unmodified binder, bio oil as well as the biochar. So here we were able to identify that in the case of bio oil, the oxygenated compounds or the oils was found to be higher. Similarly, In the case of biochar and bio-oil, the carbonyl as well as the sulfoxide compounds were also seen as it is visible from this FTIR analysis. So here you have the sulfoxide band and here you have the carbonyl band. So here you can see that the amount which is present, the bio-oil as well as the biochar, it is higher in the case of, it is moderately higher in the case of carbonyl and the sulfoxide band. So now coming to the preparation of the bio-bitumen. Here you have a bio-bitumen and here you have a biochar. So the bio-bitumen, it is prepared using a high shear mixer at a temperature of 160 degrees Celsius, 20 minutes of shearing period and 4000 RPM was selected. And so using the shear mixer, we have prepared the bio-bitumen. Similar with the case of biochar, here you have a biochar. First, we have to crush it using a mortar and pestle and then you have to add it to the bitumen at the dosages of 5%, 10% and 15%. And now you got a bio-bitumen. So now the conventional properties of the bio-bitumen was conducted. So it was found that the softening point, it was found to be increasing for the bio-oil. And with the biochar also, it was found to be increasing, but later on it was found to be decreasing. In the case of penetration, the bio-oil, with the bio-oil, it was found to be decreasing and the biochar also it decreased, which again it increased. This indicates that it has stiffened the material or it has stiffened the or it has a stiffening effect to the bitumen. That's what we are getting. Again, we can see that the viscosity with the addition of bio-oil, it has increased the viscosity and again with the biochar, it has increased the viscosity. Coming to the specific gravity of the bio-oil, it was found to be decreasing and with the biochar, it was found to be increasing. Coming to the elastic recovery, the bio-oil, it has improved the elastic recovery of the material and with the biochar, it has decreased the elastic recovery. So these were the conventional properties as we have discussed. As you can see here, the softening point, it was found to be increasing with the bio-oil and again with the biochar also, it has increased. In the case of penetration, it has decreased with the bio-oil as well as the biochar and elastic recovery, it has decreased. These were the results which we have discussed now. So now overall, we can understand that the with the conventional properties, it has given a stiffening effect to the binder overall. So now we have done certain studies to understand the aging of this bio-bitumen. So for that aging, what we have done, we have certain glass bottles and we have done the RTFO aging, basically the short-term aging. So now we have the glass bottles and around 35 grams per 35 grams of bitumen, it was poured into this glass bottle and then we have rotated it and then we have kept the sample at 163 degrees Celsius in an RTFO oven for a period of 85 minutes. So once it is done, it has aged where it is subjected to a short-term aging. So now after that we have done the rheological investigation. So basically the rheological investigation, we have conducted the frequency sweep test, the rutting resistance, fatigue resistance and the MSCR tests were conducted. So coming to the rutting resistance of the bio-oil modified binder, here we can see that with the increasing temperature, what happened to the increasing temperature and with the increasing dosage of this bio-oil, the rutting resistance was improved. So here the rutting resistance, that is a super-pi parameter, which is a G star by sin delta. So the G star by sin delta, it is indicating the rutting resistance of the binder as well as super-pi. It is super-pi rutting parameter. So here we can see that here the VG30, it is coming over here and with the increase in dosage of bio-oil, the rutting is improved or the rutting resistance is getting improved. So it is with the unaged condition. Now coming to the aged condition also, we can see that with the increase in dosage, the rutting resistance was found to be increasing. So basically it says that due to the improved or due to the stiffened binder, it has improved the rutting resistance. So with the improved rutting resistance, we can say that the temperature resistance of the binder has also improved. So the rutting resistance, it has improved under like even after the aging also. So this is the overall graph which is showing with for the aged as well as the unaged condition. So now it was with the bio oil. Now coming to the biochar with the biochar modified binder, what we can see is with the increase in dosage of biochar, the retting resistance was again found to be increasing. So here you have your unmodified binder, and here you have the 5%, 10%, and 15% biochar modified binder. So with the increase in dosage of this binders, what happens? The retting resistance has again increased. Similarly, in the case of RTFO age samples or the short-term age samples also, it has shown the same trend where with the increase in dosage, the retting resistance is getting improved. So overall, we can say that with the addition of biochar as well as the bio binder, the retting resistance has improved up to the percentage or the dosage which we have taken. So the retting resistance as well as the temperature resistance of this binder, it has improved with the biochar as well as the bio oil modification of binder. So now coming to the MSCR test results. So basically the MSCR test results, MSCR, that is a multiple stress creep recovery test. So basically the MSCR test, it is used to evaluate the retting performance of the binder, itself. So here from the MSCR test result, we will be getting the two parameters, that is a non-recoverable creep compliance as well as a percent recovery. So the non-recoverable creep compliance, that is represented by JNR, it will be giving the permanent deformation of the material. It will be giving the permanent deformation which is not recovered. That is given by the JNR. So here we can see that with the increase in dosage, that is with the 5%, 10%, and 15%, the JNR value was found to be decreasing even with the unaged condition as well as for the aged condition. So basically the JNR or the MSCR test was conducted at two stress level, that is at 0.1 kPa as well as 3.2 kPa. So we have the JNR value at 0.1 kPa as well as the JNR value at 3.2 kPa. So at the lower stress level, we could see that the JNR value, it was found to be decreasing with the unaged as well as the aged condition. And even at the higher stress level also, the JNR value was found to be decreasing. So when the JNR value is decreasing, what does it indicate? It indicates that the particular bio oil modified binder, it has shown or it is giving a retting resistant property, or it is providing a retting resistant property since due to the stiffening effect of the binder. Okay, so now coming to the percent recovery. So the percent recovery, it is represented by R naught. Again, we have the percent recovery at 0.1 kPa as well as the percent recovery at 3.2 kPa. So depending upon the increase in dosage of the oil, we can see that there is an increase in the percent recovery. So increase in the percent recovery, it says that the particular material is able to recover the deformation which has happened. That is what which is given by the percent recovery. So this increase in recovery percentage, it is saying that the material is able to recover to some extent. So it says that the R percentage, it is getting increased at lower stress level as well as at the higher stress level. It was with the case of the bio oil dosage. Now coming to the biochar modified binder. Here we can again see that with the JNR value, what is happening at 0.1 kPa, it is found to be again decreasing. So with the VG30, it was around 3.5 something, and with the 5%, 10%, and 15%, it is found to be again decreasing. Similarly, the JNR value at 3.2, it was found to be decreasing with the increase in dosages of the biochar, which again says that the retting resistance is getting improved with the biochar modified binder when compared to that of the unmodified binder, that is the VG30. Similarly, in the case of the recovery percentage also, the recovery percentage in the case of biochar modified binder, it was found to be increased with the different dosages, that is the 5%, 10%, and 50%, as the retting resistance is improved, which means that the deformation, it is getting recovered. So now coming to the frequency sweep test, which is basically the rheological property. So coming to the rheological properties, that is a complex shear modulus. So complex shear modulus, it is a resistance to the deformation. So here we can see that here it is a bit contradictory result. As you can see here, this is our BG30. So what is happening here is when we are subjected to this oscillatory shear, what happened is the stiffness of the bio oil modified binder, it was found to be lesser than that of the BG30. So this particular result, it is bit confusing. So we have to redo the testing. That's what I feel. So here we can see that the complex modulus of the BG30, it is found to be higher than that of the bio oil modified binders. So with the RTFO, it is obviously it is greater than, it will be more than that of the unmodified or the unaged binder. So what happens at the for the RTFO aging? So once the binder is getting aged, the stiffness of the binder will be more, so that the complex shear modulus will be more. That's what we can see from here. So with the bio-oil modified binder, we cannot completely trust this particular result. So coming to the biochar, here we can see that with the increase in dosage of biochar, the stiffness or the complex shear modulus, it is found to be increasing. As you can see here you have BG30, and with the increase in dosage, the complex shear modulus, it was found to be increasing. So again, with the RTFO aging, it was found to be increasing, as you can see from this figure. So now coming to the Marshall stability test, we have done the mix design for the BC. It is of grade 2. This is the gradation of the aggregate. So now coming to the test results of the Marshall, here we can see that with the increase in different dosages of the oil, we can see that the Marshall stability, it was found to be higher at the 10% dosage in the case of bio oil. In the case of biochar, we have obtained a higher stability value at the 5% of biochar modified binder when compared to the other. Again, at 10% there was a dip in the stability value, but again at 15%, it is getting higher stability value. That's what the result says. So in the case of Marshall stability value, we can go for the 10% of bio oil modification. Similarly, in the case of flow value, here you can see that at 5% the flow value was around 3.8. In the case of biochar modified binder, it was coming around 3.58 at the higher doses. That is around 15% of biochar, it was coming around 3.58 of flow value. So these were the values which we have got for the Marshall stability test. So in this particular presentation, there are certain results which is not there. I'm really sorry for that. So now I would like to conclude my presentation with these statements, like basically the bio oil as well as the biochar, it has shown good compatibility with that of the bitumen. If we take the case of the elemental composition, the elements which is present in the bitumen, it was almost similar to that of the bio oil as well as the biochar. So with the testing of the conventional properties, it has given an idea that the stiffness of the binder, it was found to be increased with the increase in dosage. Even with the bio oil also, it was found to be increasing the stiffness of the binder. So as we have seen earlier, that the superfluid rating parameter, that is the G star by sin delta, it has shown a improvement in the rating resistance. Similarly, the rating resistance of the biochar modified as well as the bio oil modified binder, it has shown an improvement in the rating resistance. So overall, the addition of this biochar as well as the bio oil, it has shown a positive effect on the payment. But we cannot, since we haven't conducted all sort of experiment based on the algae, we cannot completely say that it has shown a positive effect on overall basis. But to some extent, whatever the experiment which we have done, we can say that to some extent it has shown some positive effect on the payment performance. So many other works have to be done. These are under our future scope. So this is our future scope of the study. So basically, the different biosources uh, were not tested. So a limited number of algae species was tested or evaluated as a biomass source for the biobinder. So we haven't identified till now the researchers haven't identified the optimal dosage of this bio oil and biostar for the effective modification. And we haven't completely understood what is the mechanism which is happening between the biomaterial and the bitumen. And we haven't studied the aging as well as the storage problems of this biobitumen, and long-term performance of the biobitumen has to be studied. So these are the future studies which can be conducted in the later stages. So these are my references. Thank you.
That was a nice presentation. Thank you, ma'am. Now the forum is open for discussion.
Yeah, Anjali, this is Dr. Gautam. That is a nice
Yes, sir.
presentation. Yeah.
Thank you,
So I
sir.
had a few questions actually. One is like, have you checked the moisture resistance of the mixtures, or do you think will there be any effect on that?
So actually, I have seen certain studies on these lines. So before going for this bio oil as well as the biochar production, we have completely dried the material. So later on only we have obtained this bio oil as well as a biochar. But still, I believe that since there is a moisture content which is present, some sort of moisture damage may happen, which can be
Okay.
studied in the later stages.
And you also mentioned about there can be an issue with storage stability. Is there a possibility of any segregation happening?
Yes, what I understood is if the size of this biomass which we are taking, if it is bit larger or if the content is more, there can be a chance of this agglomeration or some kind of homogeneity can be lost over there. So some sort of segregation may happen at that time.
Okay. My last question is, see, based on your experience, what all challenges we may face while using this, even in the laboratory or in the field?
So the challenges which I felt is we took a lot of time to obtain this bio oil. Even if, as I have mentioned, around 90 grams of, from the 90 grams of algae biomass, we are obtaining around 27 something bio oil. So to
Yeah.
do an extensive laboratory to even to evaluate for this mixture level, we require that much amount of bio oil. That was the main challenge which I felt in the case of this algae oil.
Okay, thank you.
Thank you, sir.
Dr. Anjali, there is a question in the chat box. Like, shall I read it for you?
Please read it, sir.
Yeah. Are there any standard codes like IRC, IS, or more exist for algae-based materials for using in the road construction?
No, till now we don't have any standardized code for this algae. Even I don't believe like there is any research work based on this algae in Indian context.
Okay, Dr. Anjali, that was a nice presentation. Like, this is Dr. Praveen from NATPAC. Like, I would like to know whether you have conducted studies on flash and fire point of this biomodified binder.
So, sorry, sir.
I'd like to know whether flash and fire point tests were conducted, or what are the properties, how it has modified the VG VG binders, flash and fire point while adding
We
biochar.
haven't conducted this flash and fire for the modified binder.
Yeah. Yeah. Like normally, I think it's for VG grading. The minimum flash point is around 220 something, right?
Yes.
220 degrees. So since we are using bio oil, I think one of the slide I saw it is boiling point or something around 180 degrees Celsius, right? For bio
Yes.
oil. So like, how is it going to affect? Like, have you tried testing that aspect?
Actually, we haven't tried on those lines.
Okay, fine.
Anyways, thank you for the input.
Okay, fine. There is one more question in the chat box. Are there any details of road constructed in India using bio-bitumen, if any?
Are there any one second.
Details
Okay,
of
details of
road
road constructed in India using bio-bitumen, if any. So since this is the first bio-bitumen based road in India, which I think it was constructed around 2024 November something. So there is not much details which they have given. Even I have cross-checked that. They have just mentioned it is a lignin and it is under it is a collaborative work with the CRRI. So they haven't given any sort of details regarding that. It was a pilot study for 1 kilometer stretch.
So, Dr. Anjali, like you are telling that around 1 kilometer of pilot studies was conducted, right? For 1 kilometer road, right? So,
Yes.
is there any commercially available method to get this bio oil or biochar? Because you were doing this in the lab, right? You were producing this bio oil and biochar, or is it commercially available?
Algae oil, I haven't seen anywhere like as a commercial product. I don't know where we use it. I haven't seen any commercial product in regard of algae oil. Biochar, I think it will be available.
Okay, so the pilot study has been based on both, right? Bio oil and also biochar based,
Yes.
right? So could you throw some light on like how they access the bio oil in large quantities, or is it that they produce that thing, or do you have any idea?
It's not clear to me.
Like
Can you please repeat the question?
Okay, you were telling that for preparing this bio oil modified bitumen, like you need some quantities in excess of bio oil, right? So is it produced in commercial manner, or they for pilot study it was prepared by them so that they can do that in larger quantities? Because you are telling that you need this bio oil in larger quantities, right? For doing it for practical applications.
Yes, in the case of bio oil, we require a large amount, but they have used the lignin. So lignin is a kind of product which can be obtained from the paper pulp industry, as I have mentioned earlier. So the production of lignin, as far as I know, it is a bit easy than the bio oil.
Okay, okay, fine, fine. Okay, are there any more questions? So I believe there are no more questions. So
Thank you, ma'am. Now I request Dr. Gautam Saran to propose the vote of thanks.
Thank you, Ashwini. Good afternoon, everyone. On behalf of NATPAC, I would like to extend my heartfelt gratitude to each one of you for joining us today for this 28th Transpedia Research Talk on the topic Bio-Bitumen from Algae, a sustainable alternative. It has been an enlightening and interesting session, shedding light on bio-binders. First and foremost, I would like to express my sincere thanks to our esteemed speaker, Dr. Anjali Balan L, whose expertise and knowledge have truly captivated our audience. Thank you, Dr. Anjali, for delivering in an engaging and informative presentation. We are grateful for the knowledge and insights you shared with us today. I would also like to express my gratitude to all the attendees for your presence and active involvement. The questions and discussions that followed the talk showcase the interest in the subject matter, and I appreciate that engagement. Finally, I would like to thank our director, division heads, and the organizing team for the support that made this smooth execution of the program. In conclusion, I believe we all have gained valuable insights from today's technical talk, deepening our understanding on the need to find an alternative to conventional asphalt binder and how bio-oil and biochar prepared from algae can be used to prepare bio-bitumen. Thank you once again to everyone involved, and we look forward to hosting more technical talks in the series and continuing this legacy. Thank you.
Thank you.